By the end of this video, you'll know how to create a complete Azure AI agent solution. We'll build an email reminder agent for those tasks that you don't want to forget, where an email reminder could really come in handy. Now, this video is value-packed, and it's important to know that as we build this demo, each part we build is dependent on the part before it. So you want to watch from start to finish, and at the very end, I'll have a surprise for you. Now, all that said, let's dive in. We'll be building an email reminder agent. The three core features for this agent are that it takes an email, a reminder message, and a future send time. It verifies the user email to make sure that they own the email they're asking to be reminded. And it schedules and sends an email at the future date that was specified earlier. This is the general architecture for our email reminder agent. Now let's see how some of this logic will work. The email verification flow works when a user asks the AI agent to send a reminder to them, and when they give their email to the agent will create a pending verification item to verify that person's email in Cosmos DB. They'll then send an email using the Azure Logic app to send an email to the user with a code that they can then use to verify their email. The user then takes that verification code, gives it to the AI agent, and then the AI agent will check the pending verifications to see if the codes match up. If they do, the email is verified and the reminder is scheduled. If the codes do not match up, then the reminder agent asks the user to re-put in the code. Reminders stored in the Cosmos DB database are constantly pulled by a timer-triggered Azure function, checking to see if emails are ready to be sent based on their date time. Once an email is ready to be sent, it will forward it to the Azure Logic app to send the scheduled email to the specific user. Now let's talk about the order that we plan to build this out. We'll kind of be going backwards by first starting with an Azure Logic app that can send an email using Outlook. Then we'll create a Cosmos DB database with our containers for pending verifications and reminders. We'll then create a timer-triggered Azure function that can check the reminders container in Cosmos DB, and when it's ready to send a specific reminder, it will forward it to the Azure Logic app to send that email. We'll then create our agent using Visual Studio Code at first, and when we're ready then to deploy our agent, we'll create a Docker image, push it to Container Registry, which will then deploy to an Azure Container app, both the front-end chat interface and our agent in the cloud. If you want to follow along this demo step by step, you'll need a few different tools. Visual Studio Code for building your AI agent and your Azure function, an Azure account for deploying your Azure resources, the Azure CLI for deploying to your container registry and authenticating for your Azure Function Core tools, the Azure Function Core Tools CLI, which we'll use for interacting with our Azure function. JavaScript is the programming language I'll be using for this solution, so you'll want Node.js installed locally. I use Postman for local API testing. You could use this as well, or any other API testing tool you prefer. And Docker Desktop to build our Docker images that will push to our container registry and then deploy to Azure Container Apps. Anytime I'm building something new, I always like to start in a new, fresh resource group. So I have this new resource group, and let's start by creating our Azure Logic app. We'll go to the marketplace, type Logic Apps. Find Logic App, start creating our Logic app now. I'll choose consumption, make this quick and easy. The Logic app name, we'll call it LA AIS Demo Reminder Agent. Choose the same region as my resource group. I won't enable log analytics. Leave the defaults and create our Logic app. Once our deployment is complete, we'll go to our Logic app. Let's get started building this out. First, we're going to add a trigger. This will be by a request because our Azure Function Timer Trigger is going to send a HTTP request to our logic app. And also our agent later, when we're sending verifications, will also send an HTTP request to our logic app. The URL is going to be generated when we save it. Let's give it a sample payload so that it has a JSON schema to go off of. When we make requests to it, we're simply going to give it a user email, a subject, and a body. And this is what we will want to be emailed for our reminders and our email verifications. Now let's add the capability to send an email. I'll go to Outlook. I want to do Office 365 because that is the type of account that I have. Find, send an email. I'll need to sign in. Now that we have our connection created for sending an email to Outlook, in the To section, I will use a dynamic variable, the user email that comes from the HTTP request, the subject, which also comes from it, and the body. And make sure here there's a large body and small body. We want small body. Large body would have the entire body from the HTTP request. Small body is the specific JSON variable body that we've specified in our request. We'll leave the rest of these defaults. Now let's save this and we're going to test it. We'll run with a payload. And we're going to give it our example payload. HTTP status 202. So it looks like it worked. Let's check our Mason Stark email to see if we got the email. And we did. Now that our logic app is working, let's go create a Cosmos DB database. So we'll go back to our resource group, go to Create, search Cosmos in the marketplace. Find our Azure service, Cosmos DB, start creating it. We have a couple options for Cosmos DB. We're going to choose the NoSQL because we're not using any APIs related to MongoDB. Then we're going to try and keep this easy. We'll use learning as our workload type. This is cheapest and it's just quick and easy for beginners. We'll make sure we're using our resource group. We'll enter our name, Cosmos. We'll not enable availability zones. I can't choose East US, so I'll choose Central US. I'm going to choose serverless because I only want to pay for the traffic that's coming in and out of my Cosmos DB database. And then I will review and create my Cosmos DB database. Once your Cosmos DB database is complete, we'll then go to our Data Explorer. You can learn about Cosmos DB from this video. We won't do that. I'll start by creating a new container. I have to create a new database first. We'll call this DB Agent Reminders. We'll make our first container pending verifications. The partition key, which we'll use to organize our data, we'll make it email because that is the key feature for pending verifications, and also will be for our reminders container. Then we'll create. All right, now that we see or have our pending verifications container, let's create another container for our reminder emails. We'll use the existing database that we just built, and this one will just be reminders. Partition key will also be email, and then we'll create it. Now, our Azure Cosmos DB containers are set up, and we're going to go build our Azure Function in just a moment. And our Timer Trigger Azure Function is going to need some data to test. So let's add an item to our reminders container so that our Azure Function has something to go off of to test with. So we'll add some sample data in. Which will be a reminder email to Mason Stark to bake a cake. With subject reminder from an agent, we'll make the send time. Well, we'll leave the send time because it's going to be the time before today, so that the email will be sent as soon as the Azure function picks up on it. Cosmos DB adds some metadata after we save it. Now let's go create our Azure function. I'm in Visual Studio Code in a new folder I created called Demo Agent Reminder. Let's create a new folder for our functions. Then we'll go Control-Shift-P. And with the Azure Functions extension installed locally, I'll create a function. We'll create it in our current folder, and I'll end up moving the files into the functions folder. We'll create it in JavaScript. It'll be a timer trigger. We'll call this Func AIS Demo Agent Reminder. We'll leave the defaults for now and create our function. Now the first thing we'll do is take all these files and add them under the functions folder. Now let's test our function. I'm going to make it trigger every 1 minute so we can just see it working real quick. We're going to need to have a storage account or a storage emulator locally. I'll prefer to create a storage account in Azure that I'll just add here. So let's create a storage account so that it can start running properly and we can see it run locally first, and then we will add in the functionality to connect with Cosmos DB. We'll go to our resource group, create storage account, create a storage account, make sure we're in the right resource group, storage account, AIS, oh, no dashes in storage accounts, demo agent reminder, leave it East US, be a general blob storage. Standard, we'll make this local, review and create. In our new storage account, we'll come to access keys. We'll grab our connection string. Note, you should never share these connection strings with anyone publicly, but I'm removing these resources before this video is published, so it's okay. Once we have our connection string there, I'll save this. Now our function should work properly. And now let's try our function. Func start is the command to use with the Azure Function Core Tools CLI. Our timer trigger is now running locally, and we should see timer function processed request every minute. I'll speed this up a bit so we don't have to wait that whole time. And we see our functions working. This is great. Let's stop this. Now let's update our Azure function so that it interacts with Cosmos DB, checking when there is a reminder that is ready to send, and also sending a request to the logic app so that it can send an email. I'll add in all this logic. Now let's take a look at what this is doing. We bring in our Cosmos DB library. We'll rename this to the name of the function, reminder. This will work every minute. The function will get triggered. The Cosmos DB client will then be created. We'll connect to our database, connect to our container reminders. We'll query to see if there are any reminders that have not been sent and where their time is before right now. If there are reminders, then each one will be looked at, and we will send a request to our logic app endpoint with the user email, the subject, and the body, just like our logic app needs. We'll then mark the reminder item in Cosmos DB that it was sent. Now for this to work, we'll need to add some environment variables and our Cosmos DB package. Let's first install our Cosmos DB package. That's installed. Now let's take a look at these endpoints and add them to our local settings.json file. I'll let GitHub Copilot help me out with that a bit. Cosmos DB key, gotta make sure that it's correct. AI agents are never perfect. The naming is right. Let's add this. Logic app environment variable. Now we're gonna need our Cosmos DB endpoint, key, and our logic app endpoint. Just double check, that's all we need. 1, 2, 3, yes it is. Okay, let's populate these. Go to our resource group. First, grab our logic app endpoint. For our logic app, we'll go to Logic App Designer. We'll grab when HTTP request is received, and we have this HTTP URL. This is what we need. Add the endpoint in. Going back to our resource group. Let's go to Cosmos, where we'll go to keys. We'll grab the URI, which is our endpoint. And then our key. These secrets should be kept secret, and they should never be public. The only reason I'm showing them here is for demonstration purposes, because I'll be deleting all of these resources before you see this video. With all these environment variables set up, let's give this a try. We'll check Cosmos DB first. We want to make sure that we have an item in the reminders section that will be grabbed for this. Go into items. We still have, yes, sent false with the send time before, so we should get this item sent to test this. Long start. And it looks like our email was sent right away. Checking our email, and we see reminder to bake a cake. Now that our Azure Function Timer Trigger is set up properly, let's deploy it to Azure. Stop this. Go to our resource group. We'll create an Azure Function App. Functions exist in Function Apps. We'll make it consumption. We only want to pay based on the requests that are actually made. We'll call this Func App AS Demo Agent Reminder. Runtime node. Make this East US. And the storage, we want to make sure the storage is using the storage that we just created. This is it. And then we'll review and create. We'll go to our Azure Function App. And the first thing we're going to do is add in the environment variables that we need to use for our function app. So just like we have our local settings.json, let's add in the environment variables we'll need for our function app to work before we publish it. Our environment variables are in our function app. Let's add another item to our Cosmos DB database, and then we'll deploy our function that we have locally to our function app, and we'll watch it work right away. Go to our resource group, Cosmos DB. Go to Data Explorer, go to Reminders, add a new item. We'll say bake a cake. Again, a couple exclamation points. We'll save this. So now we have an item that we see was sent true, and the item we just added sent false. This will be bake a cake again, which should be picked up by our Azure function in the cloud once we deploy this Azure function. So now let's publish this Azure function. We're going to need the name of the function to do that. And we'll use the Azure Function Core Tools CLI to publish this. Now we'll publish it using Func Azure Function App publish name of the function app. And as soon as this is deployed, we're also going to start the log stream using Func Azure Function App log stream and then the name of the function to see if we can see the logs for our item that we just added to Cosmos DB to know that our function app in the cloud is working. All right, deployed successfully. And then let's run Func Azure Function App log stream, name of the function app. Hopefully we can pick up the logs before the item is sent. And we do. We can see our email that was just sent to bake a cake again. So now we know our Azure function in the cloud is working. Now that we have our Azure function built, our Cosmos DB database deployed, and our logic app able to send emails, it's time to start building our agent. Now that we're ready to start building our agent, let's talk about the development lifecycle that will follow to build this agent. First, we'll develop this agent by building it locally, and we'll just test it using the CLI built into Visual Studio Code, although you could use any terminal to test it. When we're ready and like the way it's working, we can expose an HTTP endpoint so that it acts as a backend solution, and a front-end solution can easily call it as the endpoint. Then we'll containerize our agent by building a Docker image that we can then test and see our agent is working properly in a container. And once we like the way it's working in a container, we'll then deploy that container image for our agent to a container registry and then to Azure Container Apps. Now, to start building our agent, we're going to need a resource with a deployed LLM that will act as the brains for our agent in Azure AI Foundry. So first, let's do that. I'm in Azure AI Foundry, which you can get to with ai.azure.com. We'll need to create an Azure AI Foundry project and a deployed base model that will be the brains for our AI agent. So let's do that now. We'll create a new AI Foundry resource. We'll call this project, call this AIF, AIS for AI Foundry, demo agent reminder, which will be that resource. Make sure we choose the same resource group so we can keep this all in the same place. Resource group AIS demo reminder agent. Put this in East US, which is where our resource group is, and we'll create this project. Our project is created. Now let's deploy our base model for our agent. We'll go to the model catalog and we'll choose a smaller model. We'll use GPT 4o mini. I know this is a powerful model and it's not too expensive. Let's create a deployment for this. Agent reminder. We'll add an agent reminder to the end of the deployment name. Leave the defaults and deploy it. Our model is deployed. Now let's start building this out in Visual Studio Code. We'll create a directory called agent. Enter it. And then we'll run an npm init to install a package.json file. We'll leave all the defaults. And now we have a package.json file, which we'll use to install our packages for our project for our agent. I'm going to change this to type module so that we can use import statements. Now let's start with an agent file, agent.js. We'll add in this base code for our agent. We'll also add index.js to work with the CLI. Index.js just uses the standard input and output and calls our run agent function, which is what interacts with our agent. Our agent file is just a giant function that calls run agent with input and an optional thread ID to maintain the thread history. We're going to need some environment variables added here. So let's create a .env file. We'll start with these. Our agent will need a project endpoint, which is the endpoint for our AI Foundry resource that has our model. We'll need the name of the model deployment that we made, which we'll add. And these other three environment variables would be associated with a service principal, which is an identity in Azure that we'll create so that we can interact with our Azure AI Foundry resources and the resources within our resource group. So we'll be creating that in just a moment as well. First, let's grab our project endpoint. In Azure AI Foundry, let's go to the playground for this model. We want to open up the agents playground. we can go to the View Code section and see the endpoint that's being used in the View Code section. This will be the endpoint that we want to use for our project endpoint. You can also see this endpoint in the Overview tab of your project in Azure AI Foundry. We'll need the name of our deployed model. And just before we create an Azure Service Principal, let's install the packages that we're going to need for our solution. I'll run npm install our agents package, a core utility package, Cosmos package, an identity package, and a .env and an express package. Our packages have been added. Now let's create a service principal in Azure for our agent so that our agent has authorization to access our Azure AI Foundry resource and our resource group within Azure. Back in Azure, I'll go to App Registrations. I'll create a new registration and we'll call it App Reg AS Demo Reminder Agent. Only I'll be using this, so I'll leave it as the default in my account. We won't use a redirect URI, and I'll register this application. Now I've registered my app, so I have an app registration. I have a client ID that I'll use for my client ID. I have a tenant ID that I'll use. And now I need a client secret. So let's go over certificates and secrets. We'll create a new secret. We'll call this secret demo agent reminder. It's valid for 6 months, although again, I will be deleting it before you see this video. Copy this value because if you don't copy it right now, you won't be able to see it again. So always make sure you copy the value as soon as you create the secret in the portal like this. Again, these secrets should not be shared publicly. I'm only showing them because I'll be deleting these resources by the time you see this video. I have to keep saying it because it's super important. But now in Azure, all we have is an app registration with a secret. Let's assign it some permissions. Back in our resource group, we'll go to the access control or the IAM resources. And now let's create a role assignment for our app registration. We'll give it a privileged administrator role, contributor. Next. Now let's give the contributor role to our app registration, which will create a service principal. Select members, app reg, choose our app registration. And now this will create a service principal. And we can see that we have the service principal with contributor level access in our resource group. Next, in the resource group, let's go to our Azure AI Foundry resource, and we want to assign an Azure AI Project Manager role to our app registration for this resource. This will give it more ability to interact with our agent. Azure AI Project Manager. Select our app registration and create the service principal. And we can see the service principal here as well. Now that we have our packages installed, our environment variables populated, let's take a look at how this agent works, and then we'll give it a test. We import our packages, some environment variables, create an agent's client, and then we have our run agent function. This run agent function first starts by creating an agent if an agent ID isn't specified to use an existing agent. Then there are some instructions for this agent, which just tells it to craft an email, which will be sent back to the user when it asks for a reminder. This is what we'll use and we'll start with. We'll be updating this as we go. A thread is created to maintain a conversation history. It will use an existing thread if specified. A new message is created based on the input given to the run agent function. The agent is run where every second its status is checked. Right now, it's just seeing if it needs anything to answer the question of the user. And right now we have no tools, so it should just respond right away. But later, we'll have a requires action status where our agent will wait until tools are called in order to get back to the user. The history, the latest message, and the thread ID are returned from this function. And in our package.json, let's create a starting command. We'll call it CLI node index.js. So this will call it index.js, allowing us to interact on the CLI. So let's give this a try. Fingers crossed, npm run CLI. What can you do? Our agent is created, a thread is created, a message is created, a run is created, status in progress, and then status complete. Our agent responds saying it can help us schedule reminder emails to be sent at a future date. So now this is working properly. Now let's update its functionality. I'll stop this. Let's add in a server.js file so we can host a HTTP endpoint. We'll add in this code, uses an express server, has an endpoint called chat, and calls our run agent function. To test this, I'll use Postman, but you can use any API testing tool. First, let's go to package.json to create a startup command, and we'll call this one start, and it'll be called node server.js. Now let's start this up locally. npm start. Our server is running on port 3000, so we should now be able to go to localhost 3000. And our endpoint takes a message and optionally a thread ID to maintain thread history. I've opened up my local Postman editor, and I have a base URL for HTTP localhost 3000/chat because of our endpoint that is running. I'll just message it, what can you do? And we have our response from our agent saying it can help us schedule reminders and the history of the conversation. So now this is working properly as well. Now let's add some sophistication by adding in some tools. The tools we'll add will be a handful of functions that the agent will use in order to take actions on our behalf. So for our email reminder agent to work, we're going to need a handful of different functions. We're going to need a tool that can capture the current time, current date and time. We're going to need a function that can send a verification code. We'll need a function that can verify a code. And we'll need a function to schedule a reminder once that code is verified. To get started, we'll create a tools folder. I'll create a file called function tool executor.js. I'll paste in some code. And this function tool executor will be used by our agent to help our agent call the functions as tools. There's only one function in here right now, this get current date time. Up here in this function tools array is just the parameters in the description for it. Gets the current date and time is the description. This description is important because it tells our agent how and when this function should be called. So if I ask for the agent to remind me to do something in 5 minutes, it has to know the current time in order to know what is the current time plus 5 minutes from now. So the agent will call this function to get the current date and time. The current function itself is this get current date time function, and it's referenced in this function tools array. The invoke tool method is used by the agent to actually call the function that it's using as the tools, and it passes in any parameters that it needs to. And the get function definitions method is used by our agent to get those definitions for each function so that it knows when and how to use them. Going back to the agent file, let's import our function tool executor. We'll create a new instance of our function tool executor. We'll get the function tool definitions, and then we'll add these functions in as tools for our agent. Now, when the agent recognizes that a tool should be used, it will change its status to requires action. And let's add in some logic so that our agent knows how to deal with the status of required action. This logic helps our agent determine what type of tool should be used, then what type of function tool should be used, invokes that function with the right parameters, if any, and then uses the output from that function tool, gives it back to the agent as context, and then continues the agent run and allows the agent to then respond or determine what the next status is based on that tool. We should now have everything set up so that we can get the current date and time using our function. So let's make sure we're in the right place. And then we'll call npm run CLI, because we'll try this locally first. Let's ask it, what time is it? And we can see the agent made a call to the function tool to get the current date time. And it determined this because it understood the user's intent, asking what time it was, knowing it would need to try to determine what time it was. And it didn't want to guess. So it took a look at its tool definitions, saw that it had the get current date time function, which gets the current date and time, decided to call that, and use the output to help it make its response to us. Now that we created a tool to get the current date and time, let's add in functionality to send a verification code. This way, when there's somebody who has an email and they want to get reminders sent to them in the future, they have to verify their email first, and they can't just send reminder emails at any time to any email they choose. So back in the function tool executor, we're going to need to use Azure Cosmos for this, because we'll be creating a new pending verification as part of this function. We'll add in a new function definition. Send email verification. It sends a verification email to the user's email address. It takes an email and we'll add that as part of the function. The function itself, we'll add in our send email verification will take a parameter of email, which the agent should pass in based on our tool function definition. It'll check to see if the email is valid. A Cosmos DB client will be created. A verification code will be created. And the item with the 6-digit verification code will be created and added to Cosmos DB. After that, we'll call our logic app endpoint to email the 6-digit code to the user so that they can then input it into the agent to prove that their email is indeed the one they added and asked to be reminded. I'll save this. We'll update the system message. You are a reminder agent that schedules emails to be sent to the future to a user. And we'll say, you send an email verification. You send an email verification when a user asks you to remind them of something and gives you their email. Now we need to add in our Cosmos DB endpoint key and logic app endpoint. Let's copy these over from our function local settings.json file. All right, now we'll start this, run npm run CLI, and we're going to ask it to give us a reminder with an email, and then we'll check to see if we get an email verification. Please remind me to take out the trash in 5 minutes. My email is Mason Stark. Let's see if we get an email verification. Looks like I can see the output sent an email verification. At least it says it does. Now let's check to see our email. And I can see the verification code from my agent. So that's working as well. Great. Next, we need a function to verify the code, which will call Cosmos DB based on the code that the user then inputs after they get a code from their email. So going back to our functions, we'll add in another tool definition. This function tells our agent that it verifies the email using the 6-digit code. So when the user then puts in the 6-digit code, the agent should know to respond. The first thing is to verify that code using this function tool. And the way this verify email with 6-digit code works is that the agent already knows the email from it being given previously to send the email verification. So the agent has the email in context and also gets the verification code when the user puts it in. It first checks to make sure the email and the verification code are valid, creates a Cosmos DB client, which then checks the pending verifications container to see if the verification code with that email are inside the container and are currently pending. If they are, and it comes back that it exists and that the code was not incorrect, then the pending verification item will be changed from status pending to completed, and we'll return to the agent info saying that the verification was successful. If it was not successful and the verification fails, we'll return to the agent that the verification failed and that the agent should ask for the code again. Now let's give this a try. So we'll start this over. We'll start our agent again. npm run CLI. Remind me to take out the trash in 6 minutes. My email is masonstark211@outlook.com. Now what we're going to do is we're going to get that verification code from the email that it sends. Then we're going to put that back in here, and it should use the verify with 6-digit code function after I put it in. All right, here's the verification code. Let's grab this. We'll input it into our CLI. And we can see that the verification was complete. Now we've made a tool to get the current date and time. We've made a tool to send an email verification code. We've made a tool to verify that code. Now let's add a tool to actually schedule the reminder. So going back to our function tool executor, we'll create another definition for our function tool executor. This is our schedule reminder function. This actually schedules a reminder email after the code is verified. It takes the email, reminder, and the reminder time, which should all be within the context window for the agent. And then we'll add the function itself. And the way the schedule reminder function works is it takes the parameters that the agent gave it. It first checks to make sure those parameters are valid. Then it uses a Cosmos DB client to create a reminder item, which it then puts in the container for reminders. This is when the Azure Function Timer Trigger will check the Cosmos DB reminders container to see all the items that are ready to be sent based on that send time, and will send them to the email that it needs to when the current time is greater than the send time. All right, now we have all of our tools in. Let's give this a try. I'll say remind me to take out the trash 1 minute from now. My email is Mason Stark. Now it should want to verify my email. We'll verify it with the 6-digit code. After we've done that, it should send us a reminder email in about 1 minute. Let's grab the code it just sent us. Looks like there was an error. Oh, I think I forgot to save my function tool executor. And actually, this reminds me, I do want to update my system function to make it super clear as to how to work. And I've played around with this system function in the past already, giving it strict instructions. You are a reminder agent that schedules emails to be sent at a future date for a user. You must follow this strict workflow. 1, you ask for the user's email and reminder details. 2, you call send email verification and you wait for the user to provide the code. 3, you call a verify email with 6-digit code with the code. Only if the tool output contains verified true, proceed. 4, if code verified is false, ask for the code again and do not schedule the reminder. 5, only after code is verified, call schedule reminder. Never call schedule reminder before the code is verified. When you call schedule reminder, you craft a pretty email in HTML format for the reminder and schedule it to be sent at the specified time. You always get the current date and time to ensure you send at the correct time. Giving instructions like this help our agent understand the actions it's supposed to take in the right order so that we don't send an email verification or a scheduled reminder when we're not supposed to. So now with everything saved, let's try this again. Remind me to take out the trash 1 minute from now. From now, my email is Mason Stark. We see email verification was sent. Let's check our email. We see the new code. Let's grab this, put it in, proceed to schedule the reminder. Looks like it was. And the agent says, your reminder to take out the trash has been scheduled successfully. You will receive the email at the specific time. Thank you. And in just a few moments, we should see that email. And here's a reminder to take out the trash that we just received. Now that we know this is working with the CLI, let's test this one more time with the HTTP endpoint. And then we'll move on to containerizing our agent. We'll run npm start. We are in our functions folder. Let's move to our other terminal. Stop this. npm start in our agent folder. We're running on port 3000. Let's go to Postman. We'll start by saying, my name is Mason. Could you please send a reminder to pick up the dry cleaning? Please remind me 5 minutes from now. We'll say 2 minutes from now. We'll say 1 minute from now. My email is masonstark. And I don't have a thread ID yet, but I will add the thread ID back in for when I want to respond and make sure I'm going back and forth to the same thread. We have our response. It says, I've sent a verification code to your email. Please check your inbox and provide it to me. So first we're going to grab this thread ID so that when we send another request, it knows that we are having the same conversation. So let's go to this provide 6-digit code. We'll replace this thread ID with the thread ID that we just got. Let's go get the code. In fact, actually, let's start to just see this code not work. It should break and say, hey, that's not the right code. Please send a new code. And it does come back saying the verification code you provided is incorrect. Please check your email again for the verification code and provide the correct 6-digit code. So now we'll check our email. We'll grab the correct code. We'll come back to Postman. We will provide the correct code. And we'll send this. And it says, I've successfully scheduled a reminder for you to pick up the dry cleaning. You will receive the email reminder shortly. If you need anything else, feel free to ask. In just a moment then, we should get that email. And there's our reminder from the reminder agent to pick up the dry cleaning. At this point, our agent is doing everything it needs to for our email reminder process. And now we want to containerize it so we can deploy it to production in Azure. So the first thing we'll do is we'll add a new file, a Docker file, so that we can containerize our agent. Let's add a Docker file. We'll add the instructions to build the image. I'll start up Docker Desktop. First we'll do Docker PS, make sure this is working. Looks like maybe it's still not running. It was still starting up. So now it should be working. There we go. We'll also add a .docker-ignore file so that we don't pick up our env file or our node modules in our image. Now we'll build our image. Say docker build -t demo backend agent reminder. Now I can check Docker images. See our demo backend agent reminder. Now let's give this Docker image a try by spinning up a container. Let's make sure we're in the same place where our .env file is. Now we'll run docker run --env file. Use the env file that we have currently. I'll map this to port 3000. for demo agent backend agent reminder. I think I spelled that wrong. It's demo backend agent reminder. So we're running on port 3000. It should be all the same commands we just did in Postman. So we'll say pick up the dry clean. We'll say pick up the carry out. Now this is interesting. So it didn't work. So something was off. And I just remembered the .env file, when it comes to running in the Docker containers, the .env file cannot have these quotes around it for the environment variables. Frankly, I forget why. I think it has to do with the way the values are mapped as environment variables when they're loaded into the environment by the Docker runtime. So all these quotes gone from the env file. We'll try this again. Run in that Docker file. I think we have to stop our Docker container currently. So we currently have our Docker file running. Let's run Docker stop. Running Docker stop and then just putting in the first two numbers of the container ID. So it should pick up the running container and then stop it. It gives the two numbers of the container ID that it just stopped. Now I can run Docker ps, see that there should be no running containers, and now I'll start running that container again. Now it should use the env file without the quotes around the values, and now it should map properly and be able to make a request in Postman. And there we go. So that time it worked. Said it is going to send a email verification. Let's get that email verification code. Go back to Postman. Provide that 6-digit code. We also need to grab that thread ID. Update the thread ID and the code and send this. Your reminder to pick up the carryout has been scheduled for 1 minute from now. You'll receive an email shortly. All right, and then we should get an email any second now. There's a reminder about picking up the carryout. So we now know that our containerized agent is working properly. All right, our email reminder agent is now up and running locally in a container. Let's add a container for a front-end chat-like interface so that we can interact with our agent on a web browser, which will eventually then be in an Azure Container app in Azure. I already know that I have a local container running for this, so I'll get this up and running using Docker run. Docker run, import it to the 8080. Now let's go to a web browser. We'll go to localhost 8080. And we have our chat interface. Now let's say, what can you do? Oh, there's an issue. Let's see, what is the issue? What is the issue? We need to install cores on the back end. So let's go take a look at our code for our agent. Let's add in cores. We'll need to rebuild our agent. I'll stop the current agent. Let's see, our backend agent is container ID F6. And then we'll run docker build. Tag this demo agent reminder 02. Then docker run. With the port going to 3000. Demo agent reminder 02. Interesting. Did we not install cores earlier? I guess we did not. Let's install cores. We'll build this again. We'll call it image demo agent reminder 03. We'll make sure there's nothing running, only the front end running. That's good. All right, then let's run this a new version. Let's run this Docker image 03. So running on port 3000, cores should be enabled. Now let's run this. All right, now let's give this a try. What can you do? We'll say, remind me to turn off the lights in my home in 1 minute. We'll pretend it's late at night and we've got to turn the lights off before we go to bed. My email is Mason Stark. It should ask us to give it the verification code. Send the verification code. Let's check our email. There it is. Copy this over. Your reminder to turn off the lights in your home has been successfully scheduled. You'll receive an email to my email in 1 minute from now. Thank you. And let's check the email. A minute from now, we should have it. And here's our email for our reminder agent to turn off the lights in our home. We've gone into detail on how to build this agent step by step. And if you want to create your own front end that interacts with this agent, you just need to have a front end that sends a request with a message and optionally a thread ID, and then is able to receive a response with the thread ID, the latest message from the agent, and a history of the conversation and context. If you want to get access to the code that I used for the front-end chat interface, you can find it in my online school community at school.com/Microsoft-Azure. We have over 230 members in this community learning Azure to land their Azure dream jobs. There's also a link in the description. Now our next step is to create an Azure Container Registry where we can push our container images to and then deploy them to Azure Container Apps. Let's create our Azure Container Registry in Azure now. So we'll go to our resource group. We'll go to Create. We'll create a container registry. Create. We'll make sure we're in the right resource group. And we'll call this Azure Container Registry, AIS, Demo Agent Reminder. I'll leave it as East US. I'll leave this as unsecure, which doesn't actually mean it's unsecure. It just means that it's not going to have a hash at the end. I could have a hash in here, but I think it's just easier to just not have it. So I'll use it the unsecure setting, which is still secure for reference. I'll choose the basic pricing plan and leave the rest. And create. I'll go to my resource. And it's pretty easy to get started by hitting the push an image, where it'll tell us how we can log in. I know that I can use this Azure CLI command to log in. I'm just going to need the resource group also. So in my CLI, I'll stop this. And we'll say ACR, login with the name of the Azure Container Registry. Let's grab the name of the resource group. Login succeeded. Now we need to change the name of our container images. We can go here to push an image, and you can see you want to change the name of the image with Docker tag to have the same name as my container registry, and then the type of tag that I want to push. So I'll copy this. And we'll do Docker images. And I know we'll push the demo agent reminder 03. It's going to be Docker tag, the name of the image, and we're tagging it with the name of the container registry and then the image tag at the end. Now we're going to push that new image to our container registry, since we're already logged in to the Azure Container Registry locally. The push should work properly. Now we can check our container registry, go to repositories, and see our demo backend agent. I'll wait to push up the front-end image until I have our demo backend agent image running in an Azure Container App with a URL for that backend Azure Container App that will be hard-coded into the front-end image that gets pushed to our Azure Container Registry and then to our front-end Azure Container App. Next, let's create our Azure Container App. So back in our resource group, we'll go to Create. We'll search Container App. Go to Container App, Create. We'll make sure to use the proper resource group. We'll call this ACA, AIS, Demo, Agent, Reminder. Create a new ACA env, Demo, AIS, Agent Reminder Solution. create it. Azure Container Apps need to be inside a Container Apps environment, so that's what we're creating now. Now let's move on to creating our container. Our container will pull from an Azure Container Registry. We'll select the registry. Make sure to select the right one. Our demo backend agent image. We'll select the latest image. And then we do need to add in our environment variables. So let's add in each of these. And finally, our logic apps endpoint to be able to send emails. Go to ingress, make sure this is enabled, accept traffic from anywhere, because even though our front end will be inside an Azure Container App within the same Azure Container App environment, it's still making calls from our web browser and we'll need to access the Azure Container App agent in the backend. Then let's review and create this Azure Container App. Once deployed, we'll grab the backend URL, update our postman locally, and give our backend agent in an Azure Container App a try using the full workflow. Our resource is done being created. Let's go to our Azure Container App. We should now be able to test our application URL for the Azure Container App that is running our email reminder agent. I've updated the base URL with my URL for my Azure Container App agent. Now let's ask, my name is Mason, could you please send me a reminder to take the cookies out of the oven? Please remind me in 1 minute. My email is masonstark211. I'll send this. And that worked. I have a new thread ID. I will go to add in this thread ID, and then we'll go get the code. That should have just came to my email. There it is. In Postman, I'll add this in here. And I'll send it. Your reminder has been successfully scheduled. And then in just a few minutes, we should get that email reminder to take the cookies out of the oven. And there is our email to not forget to take the cookies out of the oven. Now we need to push our front end image for the chat interface to our Azure Container Registry. I called it demo chat interface 01. So let's retag that using our Azure Container Registry. So go back to our Azure Container Registry. Grab the name of our Azure Container Registry. And then re-add the name of our demo chat interface 01. And then we'll push this to our Azure Container Registry. Push. All right, now let's check our container registry repositories, and we see we have our demo chat interface 01. Great. Now let's create an Azure Container App for that image. Go to Overview, back to our resource group. create another container app. Container app. Create another container app. We'll create this container app, making sure to be in the same resource group. We'll call this ACA AIS Demo Agent Reminder Frontend. It'll be a container image, East US. We'll make sure to choose the same container app environment we were using before. Go to the container. It'll be from Azure Container Registry. Choose the container registry we've been using. Choose our chat interface, the latest tag, and nothing else changes. The environment variable was built in. Go to ingress, enable it, accept traffic from anywhere. Go back to basics. Must be consist of lowercase. Oh, it's too long. Our name is too long. We'll say remind front. Yeah. All right, review and create. And we'll create. Our Azure Container app for the chat interface is deployed. Now, in order for the front end chat interface to interact with the back end Azure Container App agent, we'll need to add our URL for our front end to the CORS policy for our back end Azure Container App. So let's go to our back end Container App. We'll come down to CORS. We'll add this as an allowed origin and apply it. Once this CORS policy is in place, we should be able to go to our front end URL and test our agent. We'll copy this, and in a browser, go to our front end URL. And actually, this is the back end, so we'll go to our resource group again. We'll go to the front end Azure Container App. We'll grab that URL, and in a web browser, we'll go to the Azure Container App that's running our chat bot interface. All right, now we're ready to test the whole workflow in our chat interface. We'll start by saying, what can you do? Make sure that our agent is still working. It tells us that it can schedule emails. We'll say, remind me to take the cookies out of the oven in 1 minute. My email is Mason Stark. Sent a verification email to your address. Please check it. Provide the 6-digit code. Let's check our email. We have our 6-digit code. Copy this over. Put it in. Great, and it looks like our reminder email is scheduled. And in a minute, we should get that reminder email sent to us. And there's our reminder to take the cookies out of the oven, so we won't forget. We've completed the architecture for our email reminder agent. Now let's add our agent to our Mason Stark portfolio website example so that we can showcase our agent to anyone who might see our masonstark.com website. I'm in Visual Studio Code with our Mason Stark website repo up, and now let's make a new branch for the changes we're about to make to the repo. Git checkout -b for creating a new branch, and we'll call it Demo AI Agent Reminder. Now let's start this and we're going to start making changes to the Mason Stark website. Once we've made our changes, we'll push the new changes to this branch, open up a pull request, and merge it into the master. And right now we can see that it just has the first two portfolio projects that we created. Now let's update this portfolio project 3 with our email reminder agent. So the first thing we'll do is in public images, we'll add our portfolio image. I created this image in Canva, and it gives a general idea of what this is doing, where we can say remind me in 5 days. It hits an Azure Container App, uses Azure AI Foundry, Azure Cosmos DB, and Azure Function, Azure Logic Apps, and then it sends a scheduled email on time. So this kind of just gives a quick visual flow on what this portfolio project is doing for someone who's going to try to read this and take a look at what's going on and what resources are being used. Again, this is all about showcasing the portfolio project and what we know by showing the agent off. Next, let's go into our components in our source file. We'll go to project, where we'll update the title to email reminder agent. Let's also change this in the navigation, or instead of project 3, we'll call it email reminder agent. In project 3, now let's update our image. We'll add a button to allow people to try out our function. And let's add in our URL for the front end. In Azure, we'll grab our URL for our Azure Container App front end. Come back, make this the hyperlink, so that if somebody were to go to this new link, it would pull up our agent. They would pull up our chat interface to our agent, thus being able to use it in real time. Back to how we're going to change this. Again, we're only going to have one list of features, so we'll remove this and update the column lengths of these two classes. Now let's update the data. We'll add a bunch of features in there. Finally, let's update our button so that it has a little bit more space. Great. Now looking at this, this is what our portfolio project number 3, our email reminder agent, looks like on our portfolio website. We have our features, our small description, our title, an image, and the ability to try this out by going to our chat interface link and interacting with our agent. Now all that's left is to complete the process of saving these changes, pushing them to our GitHub page, and merging a new pull request into the master branch. So I'll add these changes. I'll add a commitment message. And then I'll git push, origin demo. Oh, I didn't spell origin right. I push those changes. And I'll go to GitHub. On GitHub, I'll see that I just pushed to this branch, so I can compare and open up a new pull request. I'm happy with the default. Add email reminder agent, create pull request. Some checks will occur, and then I can see the changes that I made. Once everything looks good, we'll merge it into the master branch. This should update the CI/CD for masonstark.com, and we should have our updated masonstark.com with our email reminder agent. All checks have passed. Let's merge in this pull request. We can go to our GitHub Actions and see that the master branch has a new CI/CD action that is being ran. Once this is complete, then we should have our masonstark.com updated. If I go to Mason Stark right now, I'll see that it still shows Portfolio Project 3. But once this is done, we'll be able to update this and see our email reminder agent added to masonstark.com. The deployment to production was complete. Now let's update our Mason Stark website. And we can now see our email reminder agent is showing off here. Or we can go to try it out and see our chat interface. Fantastic. You now know how to create a complete Azure AI solution and add it to your online portfolio. My goal is to help accelerate Azure learning for all. So at the time of recording, I have a special offer to help 5 technology professionals get to the next level in their career using Microsoft Azure. In this special program, I'll show you the same things I did to get my Azure job that made over $250,000 a year. Whether you're looking for a promotion or your first Azure cloud role making over 6 figures, I can help you. Check the first comment in the video to apply. If you have questions, leave them in the comments below. I answer every comment to help as many people as I can. If this video was helpful for you, I'd appreciate it if you liked the video and subscribe to this channel if you want to see more content like this. And as always, thank you so much, and I will see you in the next one.